Let's talk about exponential functions. So exponential functions have the form f of x is equal to a, some number, times b, some number, to the x. So for example, f of x is equal to 3 times 4 to the x is an exponential function where my a is equal to 3 and my b is equal to 4. The difference between exponential functions and functions we've seen previously, for example, polynomials, is the location of the variable. So you'll see on exponential functions, the exponent is up, the variable is up here in the exponent, versus before a polynomial like g of x would be x to the fourth. So I've essentially just moved where my variable is versus my constant. So exponential functions have the variable up in the exponent. And to get an idea of what these look like, let's graph an example. So let's graph f of x is equal to 2 to the x. So since we're new to this, we're going to pick some x values. We'll figure out what the corresponding y value should be, and that'll tell us a point x comma y that lives on the graph. And let's just pick out a couple of nice numbers to work with. Let's go with 3, 2, 1, 0, -1, -2, -3 for no good reason other than why not. So my y for x is equal to 3 is going to be 2 to the third because I plug in x is equal to 3. 2 cubed is 8, so I'm going to have the point 3 comma 8 on this graph. For x is equal to 2, y is going to be 2 raised to the 2. 2 squared is 4, so I'm going to have 2 comma 4 live on this graph. For x is equal to 1, the y value is going to be 2 to the first. That's just 2, so 1 comma 2 is on this graph. For x is equal to 0, y is going to be 2 to the 0. 2 to the 0 is 1. Anything to the 0 is 1. So 0 comma 1 is a point on this graph. And let's see, for negative, so x is -1, so I'm going to have 2 to the -1. I'm better at evaluating positive exponents, so I'm going to slide that down to the denominator to make it a positive one. So this is a positive 1 over 2 to the first, which is 1/2, so -1 comma 1/2 is a point on that graph. For x is equal to -2, y is going to be 2 to the -2, which is a 1 over 2 squared, which is a fourth. So I'm going to get -2 comma a fourth. And let's see, -3, it's going to be 1 over 2 cubed, which is an eighth. -3 comma an eighth is on this graph. So if I start drawing these points out just a little bit, it looks like I need, up to 3, 1, 2, 3 in the x direction, 1, 2, 3, and it looks like I need up to 8. 1, 2, 3, 4, 5, 6, 7, 8. There. That's the straightest thing I've ever drawn. All right, so 3 comma 8 is give or take right about there. 2 comma 4, give or take right about there. 1 comma 2, about there. 0 comma 1, right about there. -1/2, there. -2 1/4, there. -3 1/8, there. So you can see over here it's just going to start getting bigger, 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 faster, faster, faster. And then it's going to get closer and closer to 0, but it's never going to get there because you're just dividing by a bigger and bigger number. So this is the graph of what y is equal to 2 to the x looks like. It's an exponential function. You'll see that 2, the base of that exponential function, is bigger than 1. So as you raise it to a higher and higher positive power, as in right end behavior, you're going to raise 2 to a bigger and bigger power. That's going to get to be a bigger and bigger number, so it's going to explode over here. So its right end behavior is explosive. If you look at the left end behavior, though, you'll see you're going to put in bigger and bigger negative numbers, which means you're going to essentially be dividing by a bigger and bigger number, which is going to approach 0. So we have y is equal to 0 is a horizontal asymptote for this thing. So exponential functions typically have a horizontal asymptote. You'll also notice that it's going to go through 0 comma 1. Now, it doesn't matter for any exponential function of the form just a b to the x. If you plug in x is equal to 0, you're going to get b to the 0. That's 1. So every single exponential function of the form y is equal to b to the x is always going to contain the point 0 comma 1. Okay, well, what if we changed the base? As in, let's say I had, I'm going to use that graph again. Let's call it g of x. Yeah, my battery pen is going to be sad soon. That's okay. Let's go with 1/2 raised to the x. So this time my b is less than 1, but let's go with that same setup, x, y, and then x comma y, same locations to kind of see how these two compare. So go 3, 2, 1, 0, -1, -2, -3. So this is going to be 1/2 to the third for x is equal to 3, which means I'm going to have a 1 cubed, which is just 1, over 2 cubed, which is 8. So I'm going to have 3 comma an eighth is a point on that graph. For x is equal to 2, I'm going to have a 1/2 squared. That's a 1/4. So 2 comma a fourth. For x is equal to 1, I'll have 1/2 to the first, which is just 1/2. So 1 comma 1/2. Here's the 0, 1/2 to the 0. That's just 1, so we can see again that 0 comma 1 is on that graph. 1/2 to the negative 1. So this negative is a reciprocal. So this is the same as 2 to the first over 1 to the first, which is just 2. So I have a negative 1 comma 2. And then a 1/2 to the negative 2 is going to be the same as a 2 squared over 1 squared, which is just 4. So negative 2 comma 4. And let's see, last one, 1/2 to the negative 3 is the same as a 2 cubed over 1 cubed. That's 8. So negative 3 comma 8. So let's put these ones in green. And I'm going to go back to that same graph. So negative 3 comma 8, first one, give or take right about there. Negative 2 comma 4, right about there. Negative 1 comma 2, 0 comma 1, same spot. So 1 comma half, 2 comma fourth, 3 comma an eighth. So it looks like this. The other way. So this was y is equal to 1/2 to the x. Now you can see on this one the b is a half. That's less than 1. So as you raise a half to a bigger positive power, it's going to get smaller and smaller, versus over here it's going to essentially be the reciprocal of it, which will be bigger and bigger. So you can see that they're just reflections of each other if I could draw well enough, but the whole point in general is if your b is bigger than 1, like it is over here, then you're going to have this sort of flavor, that increasing as you move from left to right. If your b is less than 1, like it is over here for y equals 1/2 to the x, then you're going to have a decreasing behavior as you move from left to right. But those are the two main shapes that we're going to have for the graph of y is equal to b to the x, and those are, in essence, exponential functions. One application of that is compound interest, which you can see down below. There's another video about compound interest and how to evaluate that.